Good afternoon, everybody. Welcome to sort of overcast Wednesday afternoon of organic chemistry, Chem 170, with your host, me, Dr. White. Hi. Now, before we get started, I'm going to do something personal, at least my personal opinion, but I thought about it, I feel I should do this. If you have not gotten your COVID-19 vaccination, I've got both shots already of the Pfizer uh, vaccination, you should. Uh, I should tell you about my personal history. When it comes to shots, I don't react well to them. And I was very hesitant. I'll give you an example. Years ago, when I had a tetanus shot, when I had to get one, my whole left arm was paralyzed for 2 days from reaction to the tetanus shot. Yeah. And something very personal. When I don't know how old it is when they give it to you, they don't do it anymore. When we used to, in the country, give smallpox vaccination shots to newborns, I don't know how many months old you have to be. I was too young to remember, but I was told the story by my parents. What they gave you was cowpox. And I came down with a version of cowpox. It almost killed me. A story they told me was for about 2 or 3 days, I was packed in ice because I had like 105 fever. And luckily, it didn't do anything bad to me. Look how I turned out well, anyways. But seriously, I was concerned about the COVID-19 and how I'd react to it because of my past history. Well, my best friend who lives in Indiana, end of December, January, said, I already got my 2 shots. And the first one, oh, it hurt for an hour or so, a little tightness in the muscles, nothing. So I figured, all right. It took me a while to get in, as you know, it was. And I got my first shot, maybe for about an hour, a little slight tenderness in the muscles, which I just went like this, drink a lot of water like they tell you. It was gone. Second shot, Zippo. No bad problem whatsoever. And by the way, the second shot, which I got, I think it was 2 weeks ago, a little over 2 weeks ago, the level of people who needed the shots had gone down, where I go through the medical group I belong to is associated with a large hospital, or the hospital's part of the group, NCH, Northwest Community Hospital Group. Uh, they do a wonderful job, by the way. It was magnificent. In fact, I wrote a letter to the person in charge of that, thanking them. Uh, it was not that full. And from what I've seen in the news reports, it's not that full. And the other thing that why I'm saying this to you, if you read the news reports, which Dr. White's a news junkie and also a speed reader, so I do that every morning on internet. But anyways, a lot of people are getting sick now, or in your age range, if you're between 18 and 40 or 35, which I think just about everybody except Dr. White, maybe one of you isn't, or I should say is in that range, get your shot. All right, now I got that, and that is important. I felt honor bound to let you know I didn't have a problem. You should not have a problem. And in Illinois, Northern Illinois, they've opened up and it's easier to get a shot now. Oops, I don't have it open. I've got to do something.
Good afternoon. Real quick, I missed on Monday.
Oh no, I'm gonna have to send you to the woodshed. Oh no, I
What?
don't have a woodshed. For those
Where are we?
who don't
Where are
know,
we picking up today?
I will tell you in a second. All right, first to answer Tom's question, what will the game plan for today? Fun time. One, I gave my thoughts on COVID-19 vaccine, get it. Number two, I'm going to talk about test number 4. Oops, it's still broken. Test number 4. And then after that, I'll be going through the lipids problem set. Then I'm going to go through a couple of things I think you would help if I go through it. Shh, don't tell anybody I'm being nice. And next, we'll do the lab. And that's the game plan. And if all goes well, you should be out of here before midnight. Actually, it'll be quite good. All right. Does that help, Tom?
Thank you.
You're welcome. Remember, all questions are good questions. Now, does everybody see test CHM 170? Thank you. Thumbs up, people. All right. This went out yesterday at about 9:30 in the morning, and you should have gotten an email. Test number 4 on Wednesday, a week from today, 5/5. Ooh, that should be 21. Sorry about that. If you have a time machine, let's go back a year. No. Anyways, that should be 21. I forgot to change it. I will be giving test number 4 online. You'll be given the password for the PDF file for that test, which will be on Tuesday. I'll post in the assignment area, D2L, for you to get it Tuesday afternoon. On Wednesday afternoon, next Wednesday, 4, or maybe a little earlier, depending when we end, I'll send out the password for that. You'll have until next day, Thursday, to finish it and upload it with your answers to the assignment area. It should take you about 40 minutes, take an hour. Oops, that's not what I wanted. If you need a little more time, take it. Shh, don't tell anybody, I'm being nice. But it's one of those things, you either know it or you don't. And for those who have your webcam on, thank you. Now, test number 4 will cover polymers, lipids, and carbohydrates. And test number 4 has 9 pages, 20 problems. Some of them are multiple part. In Chem 170, I have never, and I probably never will, give multiple choice questions. Here's the point breakdown. General knowledge 54, nomenclature 15, reactions 36. It adds up to 105, so there's 5 bonus points. Now, if you look at this, you say 54 general knowledge questions. Well, if I ask you, is my right hand chiral or achiral? Well, that's not nomenclature. That's not a reaction. It must be general knowledge. And that's why the larger number of general knowledge, by the way, is chiral, if you didn't know that. And as always, this test, as all my tests are not open note. On Monday, I will do a review of test number 4. Also, I'll go through, I don't have it here, I'll go through the carbohydrates problem set this Monday. And we'll have our regular Zoom meeting on Wednesday for the lab and other material. Please note that the extra credit project, remember that's 10 bonus points if you want. It's optional. The deadline, this is a firm deadline, is 5/5/21. I got the year right on this one. And that's the announcement. All right. As with all tests, if you've done the practice problems and do a little study, you'll be in good shape to do well on it. And I hope you all have. Is there any questions on that? Okay. Let me remind you tonight, if you have any questions, stop by my office hour from 6 to 7:15 on Zoom. You have the link, it's in the syllabus and on the front page here of D2L. Also, let me remind you, if you're doing the extra credit project, stop by my office hour or email it to me before you upload it. I'll look at it. If there's something wrong, I'll tell you, and we can work together to fix it. So that way you can get 10, 10, it's 5 and 5 is 10 bonus points, which always helps your grade. Any questions on that? Well, in that case, let me just log off something. And let's go through the problem set. Remember, as always, all questions are good questions. Everybody see lipids problem set on there? Thank you. All right, let's take a look. Oh, Dr. White's getting lazy. It's the end of the semester. She knows. I'm going to look sad. Am I lazy or not? Yes, he's lazy. All right. What is a lipid? It's a compound or molecule or substance from something that's alive, plants and animals, that's soluble in nonpolar things, but not soluble in water. All right. Name one type of lipid. Fat is a lipid, oil is a lipid, and your hormones or steroids are lipids. Now, what I should have asked is, and I'm going to make you think on this one, give an example of a saponifiable lipid. I'll let you think, then I'll say it out loud. Everybody give up? What's a saponifiable lipid? It's another name for a fat or oil. All right, let's continue on. These are all things you should know. What's the difference between a fat and an oil? A fat is a solid or semi-solid at room temperature, and oil is a liquid at room temperature. What's yellow grease? Pig's fat. If you're cooking, you call it lard, but in the chemical industry, there are two types of pig's fat, yellow grease and white grease. Oh, I don't have that here. What's tallow? And that's beef fat. All right, let's look at the following reactions. And again, these are no new chemical reactions. You've learned this for test number 3. An ester, give the organic products to the following and look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention. Ester number 1, 2, 3. This is sort of a pseudo triglyceride, just to give you a practice. We're reacting with sodium hydroxide and water, ester, base, and water. You get back the alcohol and the carboxylate ion that you would have used to make that ester. The first ester, I get back this alcohol plus this carboxylate. The double bond will not react. Next ester, I get this alcohol plus this carboxylate. Remember, you don't break carbon-carbon single bonds. And the final ester, you get this alcohol and this carboxylate anion. And by now you've learned how to look at a molecule and not be overwhelmed by, oh, look at all that complex stuff. No, you know how to look at functional groups and parse it. All right, next one, same triglycerides, pseudotriglycerides, and we're reacting with acid and water. We have 3 esters, ester, acid, and water, acid hydrolysis of an ester. You get back the alcohol plus the carboxylic acid you would have used to make that ester. And here, once again, first ester, this alcohol plus this carboxylic acid, this will not react under these conditions with this double bond. So it's still there. This ester will give this alcohol plus this carboxylic acid. And the final ester will give this alcohol and this carboxylic acid. And here I have, ooh, this is different. Hydrogen and catalyst reacting with this. What does hydrogen and catalyst react with? A double bond. Remember, catalyst, I don't have written here, can be nickel, platinum, or palladium. You break the pi bond. Now, everybody, listen carefully. Hydrogen and catalyst will not react with an ester. I'll say it again. Hydrogen and catalyst will not react with an ester under these conditions or any conditions. Trust me, I've done this reaction on 40,000 pound batches. It doesn't. And what it will react with is the double bond. So the only change, and notice how nice I was. I said, look, and that's where you should look. You break the pi bond, each carbon gets a hydrogen. The rest of this comes along for the ride. And that's how they make hydrogenated fats and oils, which we talked about. And here, well, I gave you different catalysts. Same thing as above. Now, here I have steam reacting with this molecule. What's steam? Hot water. Remember, there's two main ways to make a reaction go faster. One, use a catalyst, which you've seen like acid or base. The other is increase the reaction temperature. And hot water will do that. It's hot. By the way, high pressure steam is a lot higher than the boiling point of water. And you should have learned about that in your general chemistry, how at a higher pressure things boil at a higher pressure. So hot water steam, what happens, it's the same as acid hydrolysis of an ester. You get back the alcohol and the carboxylic acid you would have used to make that ester. And here we have a triglyceride, 3 esters. First ester gives me this alcohol plus this carboxylic acid. No, the double bond will not react with steam, hot water. Next, you have a second ester, and this breaks to give this alcohol plus this carboxylic acid. Oops, let me move you up here so you can see this. And the third ester gives this alcohol. I haven't mentioned it, but this is glycerin plus this carboxylic acid. Now, let me move this down. We look at F, it says yellow grease reacting with acid and water. And yellow grease, tallow, and white grease, I gave to you this way of considering those 3 fats, because they're all solid or semi-solid at room temperature, but similar to what happened with an oil. But R sub S is sterile. This carbon, carbonyl carbon, plus the carbons in R is 18, no double bond. And here, the carbon, carbon, and R sub O, oleal, is 18 carbons with a double bond at C9. And here we have a R sub S, again, sterile, C carbonyl plus R sub S. So what we really have here is a triglyceride, acid and water. You get back the alcohol and the carboxylic acid you would have used to make that ester. First ester, you get this alcohol plus stearic acid. Second ester, you get this alcohol plus oleic acid. Now, third alcohol ester, you get this alcohol, so you get glycerin. I didn't put it here, and you don't have to put it. The problem asks, give the products, not balance the equation. And you'd get stearic acid again, and you've already got it. Now, tallow has the same structure in the way I'm teaching it, so you get the same glycerin, stearic, and oleic acid. And white grease, again, you should know this is the designation I'm using structure for yellow grease, tallow, white grease. You should remember yellow grease and white grease are pig's fat, and tallow comes from beef fat. Now, here we have yellow grease with steam. The reaction ester gives with steam, hot water, gives back the same alcohol and carboxylic acid you would have used to make that, which is the same as acid catalyst. So it'd be the same thing as F. And same thing, tallow with steam. Now, let's look at yellow grease, sodium hydroxide, and water. Again, this is a designation of the triglyceride. One of the R groups is S, R sub S, the other R sub O, the third one R sub S. Everybody see my little joke, SOS? Everybody know what SOS stands for? Save our ship, which is when you're sinking, you radio for help. Hopefully you don't need help when you're doing organic chemistry because it's fun. All right, sodium hydroxide, water, triglyceride ester, base saponification. You get back the alcohol plus this carboxylate anion of the carboxylic acid you would have used to get that. And here we have glycerin, first one, this alcohol plus this carboxylate anion, sodium stearate. This one, the R is R sub O. I get this alcohol and I get sodium oleate, this carboxylate. And the final one, I get this alcohol, but I get this again, sodium stearate right up here. If you want to put a 2 there, you can. You don't have to. And white grease, we use the same structure, so you're going to get the same product. Ooh, Dr. White gave you a hard one. And I think there's 1 or 2 synthesis problems on test number 4. I forgot to count them. No more than 3. Give the organic starting material for the following reaction. And what do we have here? What do we react with sodium hydroxide and water to give glycerin, sodium oleate, sodium stearate? Look above, and it would be, you could, and here you could draw the structure, give the name, tallow, yellow grease, or white grease. Then hidden all the way at the bottom, how many of you missed number 7? And that is, what is a surfactant? I didn't have room, so I didn't write it down, but I'll tell you, that's a molecule with a long non-polar tail, polar head that interacts at the surfaces of things. It's a molecule that has a long non-polar tail and a polar head that reacts at the surface of things. And that's the lipids problem set. Anybody have any questions? All right, while I was doing this, I just remembered, oh no, I forgot to tell you something interesting. Let's look at, where do I have steam? Right here. If you take yellow grease, white grease, or tallow, react it with steam, you'll get these products, glycerin, stearic acid, and oleic acid. And I worked for a company that did this. We didn't use acid, we used steam. And we called that splitting. And one day the president of the company came to my office and said to me, we sold a lot of glycerin. And he said, is there any way we can sell kosher glycerin? How many of you are familiar with kosher is? If you haven't figured out by now, when I say gay gesund, that's Yiddish, and I'm Jewish, which Jewish people speak Yiddish. Nobody else I know of. Anyways, unless you say it to other people too, but I mean, really speak it. And he knew I was Jewish. And he said, can we make kosher glycerin? And I said, sure, you're going to have to build a new plant. Why do I have to spend millions of dollars? We're making glycerin right now. Excuse me. I said, you don't understand kosher laws. Anything that comes from a pork product, yellow grease, white grease, which is pig's fat, which we are using a lot, if it interacts in the equipment you're making something, can never be glycerin, kosher. And he said, are you sure? I said, well, I'll call up the Kosher Society. They're the Union of Orthodox Rabbis, and I'll find out. By the way, I already knew my answer was right, but since there was a lot of money riding on it, I just figured I'd make him happy by calling and confirming what I told him. And I should tell you, years ago, my mother's first cousin, Rabbi Paul, was the president of the Chicago Rabbinical Society here in Chicago. And he was ultra kosher. My family didn't keep it. So I called them up, told them what it was, and they said, yeah, you were right. And I told the president, and now I'm going to teach you something. just in case you were wondering. Everybody see on their screen? Let me get some, that's not what I wanted. Everybody see different symbols on your screen now? Circle U is for the Union of Orthodox Rabbis. And this, if you see it on there, is kosher. There's another one, this is a Keruth, depending where you are in the world, different. Here's another one, that's the Hebrew chud, which is the beginning of when you spell kosher in Hebrew. But the most common one you'll see is here. And if you don't believe me, let's find out. Bottle of water, which you can buy many places. I buy this one, it's cheap, it's available at Costco. Everybody see under my nail there? There's a circle with a U. I bet you know this is kosher. It is. How do they do that? Because everything used to make that bottle and the water never touched anything with pork. There's other kosher rules depending on food, but that's the key one. And if you go to your local supermarket, look for either on a label a circle U or a little K, sometimes other ones, but in Chicagoland area, those are the ones, the main two ones. And for my personal opinion, when something is kosher, it's to a higher standard of manufacturing than something that's non-kosher. Now, interesting thing, if you go and look at most of the cookies, they're kosher. If you go and look at things like pop, it's kosher, and a whole lot of other things are kosher. You just don't know about it. Now you do. This is something interesting. Speaking about interesting, number of years ago, about when that happened, or a year or two within that, at that company, all the senior managers got copies of the Wall Street Journal every day. And there was an interesting story in the Wall Street Journal one day I read about this company in China that made different food additives, flavorings for food. And they wanted to get kosher designation. Why? Because you can charge more, make more money. And so the owner of that company called, I think it was Union of Orthodox Rabbis, and they paid to have a rabbi who makes inspections come out to the plant to see if they should get kosher certification. And the rabbi went around at the end of his inspection and said no. And the owner said, why not? We're keeping this and this. He said, because in the lunchroom, your workers were eating pork, things with pork in it. And there can't be any pork on your site. So a number of months later, that owner paid extra to his workers so they never brought pork products into the plant or things that were unkosher. By the way, in Yiddish, unkosher is called treif. And they got their designation and they could put on their products to other people who buy them. We're kosher, you can put it in your stuff, keep it kosher, and we can charge you more money. And I thought I'd teach you that. All right. Oh, we got some time before break, so let's put it to good use. And leaving my class, there are a few things you should know. I think this is a good time to review them. I didn't put it on the lipids problem set. I really should have. You should know, how does soap work? The first thing is you should know Now it's official. Soap, you should know the structure of soap is a nonpolar tail and a polar head. The important key to how soap works, how does soap work, is like dissolves like. Notice I go to much larger font. If we're on a board at ECC, I'd make it like 2 feet high. That's how important it is. And like dissolves like means polar things are soluble in polar things, non-polar things are soluble in non-polar things. And in this case, water, which you use to clean a lot of things, is the most polar substance chemistry knows of. Dirt, and yes, we've analyzed dirt. I actually worked one summer in a project at a research institute dealing with how laundry detergent worked. Dirt and grease are nonpolar. And therefore, if you try and get water to take off dirt and grease, it doesn't work that well because like dissolve like says water is unpolar, looks at the dirt, you're no non-polar. I want no part of you. However, when you use soap, let's magnify, and you should still know how to do what I'm doing. Here's a little piece of dirt. You use soap and water. You rub your hands. By the way, when I washed my hands earlier today, I was probably the only one in my neighborhood who was thinking that I made this, my cells. And the dirt is nonpolar and it tracks the nonpolar tail of soap. But more than one molecule, actually a lot more, and it totally surrounds this 360 degrees, not just in one dimension like I have it. And you should know this is called a micelle. And a micelle now has a polar outer shell because the polar heads are totally surrounding the dirt, as I showed in that picture from my slides for this chapter. And now water looks at didn't know water molecules have eyes. No, they don't. I better not pick at the metaphor, it will bleed. Ooh, that was a good one. Now water looks at the micelle and says, oh, micelle, you're polar, I'm polar, let's go down the drain together. And lo and behold, your hands are clean, your clothes are clean. If you did your dishes, they're clean. Whatever you wash is clean. And this all works because of like dissolves like. And you should know this. All right. Other things you should know leaving my course this semester. About 3 hours later, I'll be done writing this. When you eat something with fat or oil in it. And what functional group is in fats and oils? Well, you just saw ester. And so therefore, when you chew your food and swallow it, remember my mother taught me, chew your food before you swallow it well, or you'll choke, and I did, but I survived. And when you swallow it, it goes in your stomach. Your stomach has acid, HCl, which I think is one of the miracles of life, that I and you have cells that make hydrochloric acid. But anyways, and that's acid. Water is there, hydrolysis, and the functional group is an ester. And the general reaction that you learn for test number 3, if you wanted to put HCl, that would be fine too. Ester, acid and water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. And that's what happens when you consume a fat or oil. And you should know this, leaving let's make it official. It's now official. All right, let's do a B. And that's when you eat something with a carbohydrate. How do you describe, with words and a general reaction, what happens when you eat something with a carbohydrate? Well, what's the key functional group holding glucose together in a carbohydrate? An acetal linkage, which you learned about acetals and ketals and hemiacetal and hemiketals for test number 2. And in your stomach, there's water and acid. So it's acid hydrolysis of an acetal. And the general reaction, which you learned for test number 2, and I'll put down how you learned it for both an acetal or ketal. Acid, water, which is in your stomach. Keep your eye on the carbon with the 2 oxygens, and you get back the ketone or aldehyde you would have used to make that acetal or ketal, plus the alcohol you would have used to make that. Now, it turns out in your stomach, these are connected together in glucose, but you don't have to show this, but you should know this. And by the way, you should know these things for test number 4. I've talked about it. All right. Now, let's look at something else that you should know that's important. If I were to ask you to give the product or products to the following reaction, what do you do? Well, you look here and you say, oh, that's an aldehyde. On C5, that's an alcohol. and this could have been R prime. Now, when it's not in the same molecule, the alcohol and the aldehyde, you need acid catalyst, and you learn for test number 2, you make a hemiacetal or hemiketal. This reacts to that to form this new bond. And this alcohol is going to react to this carbonyl, which is really that carbon right there, to do the same thing, except it's in the same molecule. Now, whatever is not involved in the reaction won't change. So I can just rewrite everything that's not involved in the chemical reaction. Everybody with me? Next, I have the carbon here, which is this carbon, which is this carbon. Notice we'll have a hydroxyl group on it. And the oxygen of the alcohol is bonded to that, which is this oxygen. So instead of having you to learn how to do a Hawthorne structure, we'll do the world's longest, ugliest carbon-oxygen single bond, and that's that. And that's the product you get. Again, this alcohol reacts with this aldehyde, just like right here, to form this bond right here, which is this bond right there. This oxygen is this oxygen, and this bond right here is this bond, and this carbon here is this carbon right there. And you should know how to do this, both as a starting material, what's the product, or what's the starting material, going backwards. Everybody have this down before I move on? All right, the next thing you should still know and this is fructose, the one above. Did I write it down? I did, glucose. This is now fructose. And if you look right here, there's a carbon there, and this is a ketone. And as we just talked about, if you have a ketone or an aldehyde, and you react it with an alcohol, and if it's intermolecular, you need an acid catalyst. For the same molecule intra, you don't. And what you'll get, keep your eye on the carbonyl carbon. What's attached to it is still attached to it. And here's my carbonyl carbon that started out right here. So if we look here, here I have a ketone. Here I have my alcohol. It's always C5, 1, 2, 3, 4, C5. And what happens, this attacks that to form this bond, and this alcohol attacks that, the same carbon. Now, what's ever not involved in the reaction I can rewrite. Now this carbon right here is this carbon, and which is this carbon, so it will have a hydroxyl group, and the oxygen here is bonded to that same carbon, which is this oxygen, which, instead of making you learn Hawthorne, is bonded to that carbon. And this right here is this bond right here. This oxygen right here is this oxygen right there. And you should know how to do that. And if I ask you, give the product or products, you should be able to derive this. If I ask you, give the starting material, or I could even ask, give the name, you should know how to do that. And the same thing with the previous one. And that's how you do that. Now, another thing you should know about carbohydrates is this. What's the common, I can spell it. Did I ever tell you I'm the first one down in spelling bee, even to this day? Stable sugar has the common chemical name, sucrose. And you should know sucrose is a disaccharide, two monosaccharides, and they are glucose bonded to fructose. And you should know this. And on that sweet note, how you like that? We're going to take a 5-minute break. I'll see you in 5 minutes. A few more things to cover. We'll do the lab, and you'll get out early, well before 2:30. Shh, don't tell anybody I said that. Time to come back. Welcome back. Everybody back? I think so. Guess what time it is? It's Dr. White's show and tell time. I happened to go downstairs, got my mail. By the way, even though I'm double vaccinated, I'm still not going to take any chances when I go out, even though the uh, CDC, I think it is, gave new thing about wearing masks for people who are double vaccinated. I'm still going to wear mine when I take my mail in. I wash my hands afterward just in case there's something on the mail. Shouldn't, but I'm not taking any chances. But I happened to go by my refrigerator. I opened it up and I brought this along. By the way, this is Polish brand. That's what under here, horseradish. If you don't like horseradish, oh, you're missing stuff in life. But you look over here, it's made in Canada. Guess took a wrong trip from Poland to Canada. And if you can see right there, circle U. This is kosher. Now, if you don't use this, I got to find a way. Can I get some money for product placement in my class? Like they do in the movies? Nah. Now, if you're not using this stuff, especially the honey barbecue sauce, you're missing a lot in life. And I'll get to yours in a second, Tom. And if you look right here above my index finger next to the bee, why did I have, oh, it's honey. That's why the bees are there. I'll circle you. My barbecue sauce is kosher. And next time you go to the supermarket, look around, you'll see a lot of things that are. Now, so you don't get disappointed, one thing that will never be kosher certified is pork and beans. Anything with pork in it will never be kosher. I thought I'd fill you in. See what a well-rounded education you're getting from Dr. White. You're learning all the good things in life. All right, let's get back to a couple important things before we go on to the lab. Everybody see my whiteboard? Thank you. Now, the following I'll let you try this one. Give the name or draw the structure for when you react 50 glucose with 50 glucose in acid catalyst. Your turn. I'll give you a hint. It's not French fries, but it could be. And don't forget, if you haven't gotten your vaccination shots set up yet, do it. It will help protect you. All right, let's do this one. What do we got? Well, you're making a polymer glucose. You're linking it together. Remember, I showed you one of each glucose has both an aldehyde and alcohol. You can make a an acetal linkage. And what you make is starch. Ooh, this is fun. Let's do another one. And once again, give the name or draw the structure. What happens when you react a glucose molecule with a fructose molecule? It's real sweet. Uh, Nobody warned you by the end of the semester I started getting goofier. Not really. All right, let's do it. What do you have when you react glucose and fructose together? You get the disaccharide sucrose. Or you could have put down table sugar. Ooh, these are fun. Let's do another one. And I could have used HCl. I hope all of you know by now HCl is acid catalyst. And the question is, you take starch, acid, and water, what do you get? And when you're done, give me a thumbs up. Oh, I see a lot of thumbs, so I better get to work. And what is starch? Well, we just saw a polymer of glucose. And what's the linkage in acetal? And up here, when you have acid hydrolysis of an acetal, you get back the alcohol plus the aldehyde or ketone you would have used to make that, but they're connected together in starch. And what you get here is glucose. Oh, let's do one more. Your turn. What would be the product or products? Either draw the structure or give the name of the following. But you didn't realize you could have such a sweet time in my class. All right, I think everybody's done. And what's sucrose? Hold on, I see a question or a comment. Actually, if you started with candy, some of it, you'd do that too. But let's take a look at this. And we have sucrose. What is sucrose? It's a glucose molecule. If I could spell it. Oh no, I've lost my ability to spell. Remember, sucrose is glucose and fructose bond together, and this is an acetal, just like in starch. And what you get back is glucose plus fructose. And that's how you do these reactions. All right, Tom, it's all your fault now. For those who didn't see where Tom said candy, it made me think of a story back when I was in first grade. Uh, we had in our first grade class, and she was tiny compared to the rest of us in first grade. I mean, really tiny. this tiny little girl, and she had bright red hair, real bright redhead. And her family was her mother and father must have been very cruel. Her last name was Kane. Red hair, last name Kane. You know what they named her? Candy. And you know how much grief she took in first grade? And I'll bet so she got married or changed her name? Lots. Candy Cane, red, never mind. I can just remember we used to tease her a lot, which was probably wrong, but her parents must have been very cruel people.
I knew someone named Sandy Beach.
Well, I never knew anybody left alone. All right, we can do our crazy name. I did know this was a name you wouldn't want. In grad school, another grad student, her name was Susan Sweat, and she took grief too. All right, with that, it's lab time. I'm sad. One, we're near the end of the semester. My time together with you is coming soon to a close. That's sad. The other thing is, this is such a fun lab that you're not able to do in person because of the virus, but I'd rather have you safe at home than going to the lab, even though it's pretty safe. But if we were doing the labs at ECC, you'd only have to be able to do half of them, and I have to change it. And I was able to, for my class, the way it's written up, have us all online. So anyways, we'll do the lab and just imagine you're having fun. All right, when I inherited Chem 170 years ago, there's a problem. If you look at the actual face-to-face, we only have labs an hour and 50 minutes. I've taught the identical course at College of DuPage, and you got 2 hours and 50 minutes. An extra hour makes a difference, which means I can't use any of the commercially available lab books because most of the labs in there are more than 2 hours. If you're supposed to be done in an hour and 50 minutes, I can't have students working 2 hours and 10 minutes, because you might have to go to your next class if we were face-to-face. So when I inherited, I looked at the labs that were present from the previous teacher, and they were awful, and beyond awful. And being an organic chemist who's sometimes creative, I challenged myself. How can I come up with labs that I can do with the equipment I have available, and students have a good time and also learn a lot? And that's what you've been doing this. And finally, I needed one more lab. I said to myself, all right, you really should challenge yourself to the max. What area are you an expert in? And the area is surfactants. Well, how can I come up with a lab dealing with surfactants? Oh, another thing was that would cost very little money because ECC isn't going to spend $10,000 or $20,000 on equipment to do surfactant testing. And how can I make it fun? And the other thing is, how can I give my students a real life experience? And I came up with a lab, and that lab is developing competitive products. Everybody see that on the screen? And that's today's lab. Now, when I worked in industry, after the first 2 years I worked in industry, I became, because of what I was able to do, a senior research and development manager. And my job, which all people at any company's job, is to help them make money. And how did I help make money for a company I work with? Well, my research group, and I had PhD chemists, master's degrees, engineers, and technicians working for me. I think the largest group I ever had was 15 or 20 people. Usually it was about 10, 12 people working for me. We were trying to make new products for the company that they could sell and make a lot of money. Now, there was another way we also helped our company. The marketing manager, the sales manager, vice president of marketing sales would come to me, or in a meeting I'd go to and say, look, Our company is not making this product. Our competitor is, and they're making money. Help us make a similar product. That's called developing competitive products. And there you try and make something as good or better than your competitors and sell it. And you can make some money too. Because let's face it, when you're at a company, and a lot of chemists never got this in their head, I did, you're there to help make money. You're not there to do, fancy research. No, you do fancy research or good research to make the products that make the money. So if we're in the lab today, and we're not, but I'll still say it, today you're all members of my research group. And the president of our company came to me and said, we have to make a product. And that product is, I didn't bring it up from downstairs. I have some, but let me go out. Everybody see it on here? Oh, hold on. Yeah, you should see it. Miracle Super Bubbles. And our competitor is selling this stuff and we don't have anything. And in the actual lab, I give each group Miracle bottle, Miracle Super Bubbles. And I'm not going to do it in my office, but in front of the class, what I would do is take the wand out and go, and that's the hardest part of the lab for me, make sure you get good bubbles. And I blow bubbles. I said, that's what we have to do. Come up with formulations to make our own competitive product, the Miracle Super Bubbles. Now, the first thing is, what's a bubble? Oh, wrong thing. Hold on. Right thing. All right, if you blow a bubble, let's look at a magnified bubble. And outside the bubble is air. Inside the bubble is air. Then right here is a mixture of water and other stuff. And what's that other stuff? Well, if you do some search, you can find out it's surfactants. And let me tell you something, which you already know. Water is polar. What you never probably thought about is air is nonpolar. And you know light dissolves light. How do I know that? Because I just talked about it. Therefore, air and water don't mix well together. But how do you form a bubble? Well, you use a surfactant. And it forms a different type of micelle. They're different. Here, the nonpolar tail wants to be on the outside or the inside toward the air. And the polar head wants to be in the water. And that's how bubbles are formed. Because if you took a beaker of water, I gave you one of those clean blowing rods, you'd spend the next 5 years, and I will bet, and Dr. White only bets when he knows he's going to win, you'll never blow one bubble. And all around here are these, this is called a linear micelle, and this is really a micelle. A little different than the type you use for cleaning dirt, but it's still a micelle. And those the surfactant molecules interact with the water to give it tensile strength that will keep the bubble there. and that's a bubble. Now, when you do research, there's a couple things that are important. Dr. White, me, was very lucky that when I started in grad school, my research advisor beat into all our heads, when you do an experiment, only change one variable. When you do an experiment and do a series of experiments, only change one variable at a time. Because if something doesn't work and you change two different things and now it works, which made it work? And therefore you don't know and you got to go back and do more work. That's one thing. The other thing, which I know quite well being a senior manager, is how to do what's called DOE, design of experiment. And that's where you set up a grid or a series of different experiments where technically you're only changing one variable at a time, but at the same time, you can test a lot of things together. And Dr. White knows how to do that. Now, what are we going to be testing? If you look at patent literature, and patents are a way of protecting what's called intellectual property. Remember in the old days when a miner would strike gold and he'd go to the assay office in the government and say, this amount of land, I'm claiming all the mineral rights? Well, patents do the same thing, but with intellectual property. And in chemical industry, there's three types of patents. One is composition of matter. Here's the actual structure of a new molecule. Nobody else has gotten it. It's mine. Once it's granted, you get a patent. You have that. You're the only one who can use that molecule for 20 years. Now, the second type is called an application patent. That's where you can either create new molecules or use existing ones, and you use them in a new application, either a mixture differently or other, and for 20 years, you're the only one who can do that. Now, the third one is called a process patent, which are not easy to defend, which I have a new way of making this in a plant. And those are rarely, you don't want to do that. Those are the hardest to defend. By the way, if you have a patent, the only strength behind it is you're willing to sue someone who's violating your patent. The government doesn't step in. You got to sue them. If you listen in the last 15, 20 years, you hear in the news once in a while, Apple suing Google suing Apple, or other companies are suing other companies to protect their intellectual property, their ideas, and the ideas make money. Well, if you look at the patent literature, and you can do that by the website that's probably the second most website on the internet I visit. Google is number one. The other is the US Patent Office website, which you can look up patents. If you look up patents on bubble blowing, there are a lot of them. I should tell you that to have a patent, if you have a company with attorneys, your attorneys spend a lot of time, which is money, doing that. And when you go to the government office, I'm not sure what it is today, but in the past, it used to be $5,000 filing fee. If you don't have a patent, you're a patent attorney, you're going to spend another $50,000, $100,000 to have them write the patents. Then you're going to pay people like me to develop it. So if you file a patent, one, it's going to cost a lot of money, and two, you believe you're protecting something that's worth a lot of money. So if there's stuff on bubble blowing, it's quite lucrative. And by the way, it's mostly water. And one of the things in the chemical industry I learned very early from a mentor there was, if I can sell you a product with a lot of water in it, I'm going to make a lot of money. Because if I'm selling you a bottle, a gallon of something for $5, and 95% of that is water, which is the cheapest chemical you can buy, I'm going to make money. But anyways, that's a story for another day. Now, what are good surfactants? And there are three surfactants you'll be using today. And let's go look at the lab, and then we'll come back to the whiteboard. Like I said, you'll be testing this and you'll be using dishwashing soap, liquid hand soap, and detergent, along with some other additives I'll explain in a little while. Now, let's look at the structure. All right, everybody see three surfactants on their screen? Uh, Zoom is getting zoomy on me. And the dishwashing soap we'll be using is Dawn. If you know how to research this, Dr. White does. If you know how to read labels, Dr. White does. Don't forget, the extra credit project is deadline is next Wednesday. Come to my office hour, email me if you want me to check your project before you hand it in. Remember, it's optional. Give me a second. I always, come on. This is called sodium lauryl sulfate. And this has got a polar head. And R sub C sub 12, or just R, is 12 carbon CH3, CH2, CH3. And this part is also nonpolar. Next, you'll be using a liquid hand soap. It has a similar structure. And this is called sodium lauryl sulfate. And here you have a non-polar tail. And here is your polar head. And finally, we'll be doing a laundry detergent. And the key ingredient there is this linear alkyl sulfonate. And this is 9 to 12 carbon, CH3, CH2, and so on. And this is your detergent molecule, whether you use whatever brand. And this is nonpolar tail. And your polar head. And these are the three surfactants. Now, if you read the patent literature, there's certain additives that help make blowing bubbles better. And one of them is glycerin, which has 3 hydroxyl groups. And it helps in the hydrogen bonding of the water to the polar head of the surfactant, and it's called increases the tensile strength of the bubble. Another one can be either starch in water, or corn syrup. And both have molecules with a lot of hydroxyl groups. Corn syrup is really fructose, which has 6 hydroxyl groups. And similar in a way to glycerin, and starch is a lot of glucose molecules linked together with a lot of hydroxyl groups. So it's your job to find out which works. Now, in part A, you'll be using the dishwashing soap, Dawn. And what I have made up, and you would do this, is a series of different experiments. In a beaker, you would put in some solution A1, 2 milliliters of the dishwashing, 18 milliliters of water. A2, we've doubled the amount of dishwashing soap, so concentration is a factor. Now, here we have A3, which is what's ever left of your A1, and putting in some glycerin, 5 drops. A4 is more dishwashing soap and more glycerin. And finally, A5 is make another one. And I used to use corn syrup, but I found high fructose corn syrup. The corn starch was easier for students to handle when I make up a solution. And you make this, and this is a different type of additive. And you use A2 again. Now, the question is, how do you test what you make? Well, there I have to get ingenious. Dr. White can sometimes rise to the occasion and do that. The school wasn't going to let me go out and buy the equipment to test bubbles, because that's hundreds of tens of thousands of dollars. So I came up with an idea, and it worked pretty well. I had students measure from the time the bubble came off the wand till it busted, how long did it take in seconds? And when you do each one of those tests, you have to measure at least 5 bubbles. And sometimes you may have to blow more than 5 times, because I found out not all students watch SpongeBob teaching Squidward how to blow bubbles. It was funny. In a class, sometimes one partner could barely get one bubble out, and the other partner was like a professional. And the one who couldn't got upset sometimes. I said, relax, you're great as an honor, and you're lucky you have a partner who will help out. The other thing I have to remind students, when you blow bubbles, don't inhale. It doesn't taste good. And I've seen that in students do. You don't go, but anyways, and I show them how to do that. No, I don't spin around like SpongeBob, but I did watch. And Dr. White still likes his cartoons. The more complex the mind, the simpler the relaxation has to be. My mother never bought that. But anyways, you blow bubbles. And if you notice over in table A, I've given you the data. This would be the average of 5 bubbles, 10 seconds, 8, and so on. Now, if you notice, I have a commercial product, and this is called the benchmark. And the benchmark is you've got to get a product that's similar or better than this, or you're not going to sell it. And think about it. What kid wants a bubble blowing solution that you can't blow bubbles easily with? And this tests that. So we do that. Now, when I do have the lab, we do that before you go into the lab. I'll tell the students, please remember good, proper etiquette. It's not polite to blow bubbles at your neighbors. It's not really polite to blow bubbles at Dr. White. And the last thing, which had been a problem at times, you shouldn't be busting your neighbor's bubbles when they're timing it. That's not nice. Also, safety thing, the bubbles go down the floor gets slippery wet. Every once in a while, take some paper towels and wipe it up. Now in part B, we're going to change the variable. And the variable is, instead of using the surfactant from dishwashing soap, we'll use the liquid hand soap. And we'll do a similar thing, measured how long a bubble is available or until it busts. And here, notice I have a B1, which is similar to A1, but the only thing we've changed is the surfactant. And B2 is the same thing. We've increased the amount of surfactant. Now you're seeing the beauty of design of experiments. And here it's twice as much surfactant here. And B3, we have all of B1. And by the way, warning, the next name, I always do this, I can't help myself. But it was B1 with some glycerin. Next one, B4 what? Never mind. But anyways, take all of B2, 10 drops of glycerin. Notice it's similar to what we did in table 1A, except now we're using a different surfactant. And finally, B5 is B2 with a different additive, cornstarch, a lot of it. And you blow the bubbles, and here we have the results. Now, one of the things I didn't mention is when you're doing these tests, I have a special, I guess you call it a rule or thing you should follow. If you take 10 times, 10 different attempts at blowing a bubble, and you can't get one bubble, put down 0 for the time the bubbles last, because you couldn't get any, so it's 0. Again, you don't have to redo the commercial product. You just copy it from the first page or first time you did it. And here's the results. And finally, in part C, not finally, almost finally, we have using the laundry detergent. And what have we changed? We've changed the surfactant. And notice you have a C1, similar amount as in A1 and B1, except a different surfactant. And then we double the amount. Then we take each of these formulations, you add glycerin, see how that affects it. And then you add, for this last one, C5, make another C2 up here and add a different additive, a lot of it, 10 drops of cornstarch. And again, you'll see, oh, that's not good. I'll come back and talk about this in a second. You couldn't blow any bubbles. Now, a number of years ago, after I'd been doing this for a couple of years, excuse me, there was an itch in my ear. Now it's no longer itchy. But anyways, after a student came up to me and said, Dr. White, can I try my own formulation? I said, that's a great idea. Go for it, as long as you use the chemicals I have out. And they did. And they came up with some pretty good ones. I think it was 3 summers ago. I had one student, they had their formulation using glycerin, and I think it was the liquid hand soap and water. And they blew a bubble, and it lasted 5 minutes. The whole class stopped, and we're just watching the bubble. And finally, it hit the light on top, and everybody, boo, or it would have kept on going. It was like the bubble that didn't want to die, and I can still remember it, and it was amazing. Now, the other thing I needed to do, if you were in real life in a lab, hold on, my eye issues now. Uh-oh, I'm itching all over the place. Anyways, how do I give students a real life experience? And what's that real life experience? And that is, if I'm the manager and you say, oh, this works, here's a new formula, let's go to the president. And I'd say, whoa, no way. I'm not sticking my neck out. Show me it works. When the big boss is looking, it gets harder to do things. And I'd have students, they would have to take their, whatever they consider their best formulation, and each student had to blow 2 bubbles, and then the fun started. It was always fun. They eventually got their 2 bubbles, and I'd have to sign off on it. And in real life, any report that came from my research group, on the front page, would have the name of the research and their signature. As the manager, it would have my signature on it. My signature didn't go on there until I proved everything. And it would get issued by our secretaries and go out, be mailed out or emailed out, whatever, depending on what year we were working, unless it had the manager's signature on there. And part D, if you want to try what would be a formulation, and unfortunately I didn't put anything in there, you can leave it blank. And part E, what I would do is you have to blow your best bubbles, then I'd put my initials here, just like in real life. And that's the lab. And here I have different questions. But before I go, I'll tell you a nice story. Actually, two nice stories. First one is, having been an expert, and I still am an expert in surfactants, I worked at one company, Unichem, and because of, hold on, I'm having a bad hair day. I'm gonna have to get a hat for my hair. But anyways, Tom, that's why you're wearing a hat. Never mind, I'm just kidding with you. But anyways, I worked at Unichem, and part of my job, the research center was also on a plant. And we had these monster waste treatment plants because we were taking fat and splitting it, steam, to make glycerin fatty acids. And city of Chicago had very strict limits of what sort of things we could put out into the sewer. And we had to have waste disposal ponds. Well, at that time, there was still anyways, somebody pumped something in our waste disposal pond that shouldn't be in there. And all of a sudden we had this foam on top. And foam is just bubbles, really, think about it. And just lots of them. And it was inching toward 35th Street. It went over to, we had these about 4-foot high earth dams around this to protect keep the water in these. They're about 1 million gallons apiece. About each one was the size of a football field, about 20 feet deep, big. And it was creeping toward 47. And if those foam hit 47, we'd get charged, fined a lot. So the president of the company and my boss said, "You got to get rid of that. Stop it." I didn't cause it, but I had to clean up somebody's mistake. So I quick got some small samples of the foamer. By the way, any chemical or product that's sold, chemical companies, you can call them up and they'll send you samples free. Depending on how big a customer you could be, you can get up to 5 gallons. And I've worked where actually it's called the sample room, and I also manage the sample room. So I got some surfactants, and there are two types of surfactants. Today's lab, you'll be learning about surfactants that make bubbles. In fact, some of the soaps you buy, they put in surfactants that don't help clean, but just make bubbles because your condition, ooh, bubbles, that must be good stuff. There are other surfactants that stop foam called defoamers, inhibit bubbles. And I found one, and because it was so important, and because we had about 1 million gallons to treat, I had about 5 drums, that's about 250 gallons, airlifted from California overnight to our plant. We put it in, knocked it down, stopped it, and that cost a lot of money. And the plant manager caught hell because they dumped something in there that they shouldn't have. So that's one sort. I went to another company, and I again was a manager. And this company had a nice thing that was already in place, tradition. That was every Friday afternoon at the end of work, the R&D managers, a bunch of us, and I found out about it, and I would go to a local tavern. That's using the word. It was like a hole in the wall, no windows, a couple tables and a long bar. And we do some beers and gripe about our employees, gripe about upper management, what idiots they were. And if you're at my level, some of the CEOs and presidents of companies are really idiots. You wonder how they got there. But anyways, and we then leave and go home. But anyways, the owner of this tavern had a, what would I say, interesting skill. And his skill was in a pitcher of beer, he could put a third of it as foam. And if you complained to him about it, he'd say, well, go somewhere else. Well, I wish I could say it was me. I wish I could say it was me. But another manager who knew surfactants as well as I was really upset about this. What he didn't tell is he got a sample. Now, I talked about samples you can get from chemical companies. What you don't know is there's two main kind of chemicals you can get. One are industrial chemicals, the other are food grade chemicals. And food grade chemicals, not only are they chemically pure, but they're biologically pure. No ickies in them. You can see I have biology, not. But anyways, no microbes or anything. You can consume it. And he got a small sample, a nice size sample of defoamer from the company, and he put it in a little squeeze bottle. He had a suit. We all wore suit and ties. We went to this, and he didn't tell anybody. And when the owner wasn't looking, we finished one pitcher. He said, shh, don't tell anybody. And put about a milliliter in a little beer in the bottom, went like this, coated it, and said, hey, we need another beer. If you ever been at certain bars, they have a sink for their pitchers of beer. That one is soap and water, and then a rinse or two rinse sink. Well, by our second pitcher like that, it contaminated all three sinks with defoamer. And the guy couldn't put a head on the beer, no matter, oh, he was getting upset. We stayed longer that night and we had a few more, and we were laughing our heads off. And he finally figured out, you guys are scientists, you did something. No, we didn't. Get out of here and never come back. And we found another place that you got full pitchers of beer. So there are two types of surfactants. One are foamers and the other are defoamers. And the reason I tell this story, if we were in the lab, I'd be walking around, but we're not. And I'd say, can anybody explain why you're not getting bubbles with the laundry detergent in part C? Right here. Look at, nothing happens. Or maybe you'll get 1 second or two. Can anybody figure that out? Anybody want to jump in? Let's see, what are bubbles? Foam. What would stop bubbles? The story I just told you. And in laundry detergent, you don't want foam. You have a defoamer in it. And that's why you don't. Now, it's happened twice. One where a student came up to me during this lab and said, after I told everybody about the all, said, I did something stupid when I was younger. We ran out of laundry detergent. I put in dishwashing liquid in my washing machine. And by the way, that does have a foamer in it to give a lot of foam. He said my whole utility room was covered in foam. Another student, I think it was her, or him, but I'm not sure, said, oh, I had a friend who put in another lab laundry dishwashing detergent in the washing machine, and it foamed all over the place. So don't. And with that, I'm done. That's our, oh, wait. And now I'm done. Now you know why I'm sad, because it's fun watching students blow bubbles. And with that, I'll say, I'll see you on Monday. Don't forget, Monday, 1, I'll be doing my world famous review for the next test, test number 4. And then I'll also go through the carbohydrates problem set. And if you need help, I have my office hour tonight. And with that, game goes on. Goodbye. I lied. I got it out after 2:30.